Hello, this is a short video to show how to run and how to debug a Flask application for the workshops. We will use the Flask application for day one, and we will first run it, and then afterward we will show how to debug it. The structure of the Flask applications for this course is this way. We will have a train folder which contains the training script train.py. We will also optionally have a data folder that may contain the data sets. Sometimes the data is not locally stored but downloaded elsewhere or shared from another place. And finally, we have the Flask application, which is under app, and there are a few files here. We have the main entry point, run.py. We have an environmental settings file, flask.env. And we have a demo folder which contains the actual application, the demo application code. So the entry point is where we would start running the app. So let's give it a try. You can run the app by using the Python terminal, going to the file and typing Flask run. So in this folder, we have the Flask env file, which you may not have, so you may have to create it manually using 3 lines. First line is the entry point, run.py, which refers to this file. Second is the environment, which can be development or production. And finally, we have the port number that we can use to access the web server. So in a typical Flask app, we would actually not do Python run.py. We would actually do Flask, which is a program that is part of the Flask web server framework. And we would just say Flask run. Flask run would actually pick up the settings from these environmental settings like Flask app, Flask env, and Flask run port, and just call whatever is assigned to this setting. So when I do a Flask run, you can see that it's serving Flask app run.py, environment development, and debug mode is on because in run I set app debug is true. Okay, and it will take a little time, but you will see that it's also running on port 8080. Okay, this 8080 comes from here. So you see that TensorFlow is also loaded. This is because we have code in ml.py that imports TensorFlow, and we also create a TensorFlow model. Okay, so let's actually check out the app. So you can go to here and you can click, and it will open a browser window with that URL, port number. Okay, and if you type for day one, this is a sentiment classifier. So if I type any text, it will reply with "you seem sentiment." Okay, so this is the prediction from the model. Next, let's try to see how we can debug this. First, I will close this by doing a Ctrl+C. Okay, so I clicked Ctrl+C. And now I'm going to try to debug this. The debugging process is quite similar to debugging any Python file. Our entry point is run.py. So we can just naturally put a breakpoint here by clicking on the line. And then we can do run debug. Okay. So run debug should automatically detect that you want to run this file that is open at the top. Okay, so you can just do run, and you will see connected to PyDev debugger. And you also see that TensorFlow is being loaded. So now we are stopped here. You can tell that it stopped because this line is highlighted. We have some frames here showing the code line number that we are stopped at. And we have some variables. This particular one is a Flask app, so it has some settings related to Flask. You do not have to worry too much about these right now, but they are worth checking out if you do want to configure and tune the app, as in you have to customize it for your needs. So the only thing we've set here is just that we are debugging. So I'm going to go into my code. So let me actually set another breakpoint. I will do it in views. So if I do it in views, I want to set the place where I'm actually doing model predict. So let me just do it here. And from then on, I can go into my code. Okay. So now it's broken here. It's waiting for me to finish rendering default.html. Okay. And my default.html happens to be here. HTML file with a chat window. So I will let it load default HTML. And going back to this page, you will see that it has loaded. Okay. So now let's actually predict some text. So I made a mistake, haha. And now when I do that, when I enter into the press enter, it would actually call this function called reply. And reply is actually a post method which has a request coming in. And I'm going to use this text to predict. Okay. So where is this set up? This is actually set up in the JavaScript. Okay. So when we go to the JavaScript, there is a AJAX call. This is called asynchronous JavaScript. Okay, it's using jQuery, so this syntax is jQuery syntax, right? And you can see that there's this thing called AJAX, which is asynchronous JavaScript call, right? Asynchronous JavaScript and XML is really what it means, but nowadays we don't really use XML anymore. We use JSON. So this, when I submit my reply, which is, whatever that I typed, it will come into this JavaScript function, and then it will append my message to the browser client, but it will also make an asynchronous JavaScript call to this URL called reply. And this is the same URL as this. Okay, so this is important to note, that when this is making this AJAX call on this //reply, is actually going to call my own function, which is routed to this post method. Okay, and I will get this input to my request.form. Okay, so here's the form, right? Form.serialize. This is the request. Is a post. This code is called after I finish, when I get a response back from my model. This code is called when it's failed. Okay, so currently it has posted the data over to me. It's waiting for my response. Okay, so this is the flow. So if I debug over this, okay, I can see that my text is this that I just typed in the browser. Right, I had typed this in the browser. I press enter. Okay, so we're still here. Now I'm going to get the predictions on the model. So I'm going to step into my code. This is calling my ml.py, which is this TF model class. Okay, the TF model class loads the model on startup. Okay, so it has the load model function, and it also creates the label encoder and vectorizer to be used later when we do predict. Okay, and then when we do predict, all it simply does is get the input data, which is still this, create a vector. So I'm going to step over this. You see that X is now a vectorized representation of these words. Okay, the word I will be 4, mate will be 83, and so on. These are 0 padding because I have set my sequence length to be 17. I'm going to call model.predict, and model.predict is basically calling my machine learning model that I've trained and loaded. So if I step over this, you see that it takes a little while, but it returns my y, which has 14 values. Okay, and let's take a look at that. Okay. So it's hard to see the values here. So let's go into the console. Console is a way to run Python code at the current state. So if I look at my y, notice that it's actually just an array. Okay? Sometimes it's easier to see it from the console, sometimes not. And you can also click View as Array, and you will see that the array value is here. Okay? So that's a helpful thing to do. But if you prefer more directly, you can just type y here, and you can actually look at more details of the model. Okay, for example, if at this point you are trying to figure out what model is this, you can call model summary, right? And you can do anything basically to execute any code here. Of course, it may, if you change the state of any variables here, it may affect the program. Okay, so self-label encoder inverse transform. Okay, so what is this? This is basically doing an inverse transform of y. Okay. Let's just try that again. Copy this code and paste. That would actually transform the y value, right, which is currently 14 to excited. Okay. So apparently this text, or the input text, which is data, is considered excited. Okay. But this is more of an issue of the model's accuracy. Okay. If the model is more accurate, perhaps it would give a better result. Okay, so that's kind of the overview of how to debug. The most important part for this class is really understanding how the model gets loaded and how the prediction can be retrieved. There are, of course, other frameworks like in like Node.js, or you can even do it in Django for Python. The idea is still the same. You load the model and then you call it from a web server. And to stop debugging, you can always click stop, and you're done. Hope this is useful. Thank you.